Hello, I am Manoj and I'll be presenting you the UV app that we have created for our final project for ECE 513. The group members for this project are me, Manoj, Dario and Negar. This presentation will be divided into three parts. First part, I'll be going through the particle device code and implementation. Second part will be focused on the server implementation and the challenges we faced. And in the last part, I'll be taking you through our website that we have created for showing the interface of this app. We'll start off with the state diagram that we created in order to meet the requirements that were set for this project. We start off with the wait state and we continue to stay in wait state until we get a start signal. Start signal is usually the pressing of the setup button on our Photon device to go to the record state. In record state, we first switch on the LED and we start recording GPS values and the UV values at 1 second interval. After that, we go to the check speed state. In this state, we check if prior to speeds are or were zero. If not, we go to the record state. But if we have prior to speed values equal to zero, we go to the pause state. And we stay in the pause state until we get a sample value of speed which is greater than zero, and then we go to the record state. From check speed state, we have two more conditions we check for. Is one is if the stop button has been pressed, and the other one is if tick is greater than 15. The value 15 is chosen by our group, and we actually use 15 we actually use 15 values to aggregate and then send it to the server, which brings us to the next state, which is the aggregate state, in which we average out the UV and the speed that we have collected for the past 15 seconds. We also sample GPS location at this point, and then we go to the check Wi-Fi state. From here, if we have Wi-Fi, we go to the post data state, which posts the data to the web server that we have created through webhooks, and then we go back to the record state. If we don't have Wi-Fi, we go to the store state, in which we store the data that we have collected. From here, we can go to the post data state if we get Wi-Fi connectivity back. We will be staying in this state if stop has been activated. We also check if the data has been stored for less than 24 hours. If that is true, we go to the record state. If not, we go to the delete state, where we delete all the variables and the data that we have collected, and we switch off the LED to signify that we are stopping the recording, and then we go to the wait state. From post data state, we check if we have a stop signal activated, and then if yes, we go to the stop state. In here, we clear all the variables and we switch off the LED that we switched on during the record state. After this, we go to the wait state and this cycle continues. We have implemented the alert system for showing the UV threshold has exceeded the limit that has been set in the wait and the record state. So the state machine for this alert system starts off with the wait state. We check if the alert is true. If it's true, we go to the alert state, where we switch the main LED to red, and then we go back to the wait state. We continue in this loop until we get an alert value which is false, and then we go to the no alert state. In this state, we switch off the red LED and then we go back to the wait state. So the requirements met for the Photon devices are that we have created a start and a stop button, and we switch on and off the LED depending on whether we are sampling the data or not. We have sampled data at 1 second interval and we are sending it after 15 seconds to the server. We have handled the pause state, which stops collecting data if we have more than two consecutive samples speed equal to 0. We have also implemented the store data state, which stores the data for 24 hours if Wi-Fi is not present. And lastly, we have implemented an alert system which alerts the user if the activity was more than, if the threshold exceeds the threshold that was set. Next, I'll be going through the server implementation. I would like to go through the schemas that we have used to store data. The first one is the user schema, which stores the user email, full name, and the password hash. Second is the device schema, in which we store the device information like API key, device ID, and we link it to the user through the user emails field. Lastly, we collect Photon data in the Photon schema, which stores the API key and the device ID, along with the values that we get from the Photon, such as the location, UV sensor values, speed, and the submit time. Submit time is the time at which the data was submitted. And we also have two extra fields here which segregate the values from one another, which is the activity number and the activity type. So we separate out the activities based on the speed and the time interval between the activities that we get from the Photon device. So we have implemented the server such that an activity will be considered, so two consecutive activities will be considered different only if the speed of the activity goes over a certain threshold that is set for an activity type, or B, if the time interval between the activities is more than 40 seconds. So threshold for walking. So we have said we have four types of activities that we can register. One is the first is the walking threshold. First is the walking activity, which has a threshold of 2 kilometers to 5 kilometers speed. Running threshold is between 5 and 10 kilometers per hour. Cycling is above 10, and standing is below 2 kilometers per hour. So other way to distinguish between two activities is if the activity is sent after 40 seconds. So we have kept a margin of 25 seconds for the data to come from the Photon device to the server. So if not, we are considering them as two different activities. And we have access to the and we have made access of the Photon data to the web server through an API key that we have generated uniquely and given it to the user when they register the device. So server-side implementation, we have used RESTful APIs. We have used the CRUD implementation. We have used GET request to retrieve data from an endpoint. These endpoints are usually used to retrieve user device and Photon data that has to be shown to the user. Second is the post endpoints, where we save the incoming data for, let's say, a new user or Photon device or a new user information. Third is the update. To update on server, we have used put requests. So these endpoints usually update the information that is already stored on the server, such as the device info or the user info, the Photon data info. And lastly, we have the delete endpoints, which remove the data that was stored on the server. We faced two major challenges during the implementation. First was due to the asynchronous behavior of queries and the way in which we have designed our schemas. So in order to retrieve data from the Photon schema, we have to start with the user schema, get the email of the user. From the email, query the device's schema to get the device ID. and from there, from that device ID, we can link it to the data photon data schema. So it's usually a two-step process, two query process to get to the data that we want to query. So this was faced, and then we were able to resolve this problem using promises and callbacks. The next major hurdle we faced was for aggregation of data. So aggregation of data on the server using was a major hurdle that we had to face. So this was resolved using an aggregation method in the MongoDB. So MongoDB, along with aggregation and methods such as match, sort, group, and project, we were able to aggregate and reshape the data so that we can get the data in the format that we wanted to show, that we wanted to be sent to the front end. And since it's being done, since these queries are being done on the server side, they're usually more optimized and more time efficient. And this was a major milestone in the project. Other server implementation methods which were used on the server are update one, update many, and find one and delete for the endpoints. So the server side requirements that we met were, so we have created endpoints that save an incoming data from a Photon device with an API on the authentication. We can create new users and save their information. We can update their information too. We can retrieve proximity users and all users data, and can be shown on the user's profile page. We can send alert to the particle device using their own account, and we can also delete or add new devices in their account. Next, I'll be going through the website of our app. So this is the homepage of our app. So I'll be going through two processes. First one, I'll be showing you the uh, functionalities that we have implemented, and in the on a new, so we'll start off by creating a new user and going through all the processes. Secondly, I'll be showing you the summary data and the graphs that we have generated for the user to be seen. So let's start off and register ourselves. So I'll be using test. My password is also test, and confirm password is also test. And if I press register, you'll see that we have error messages saying that we should have correct email addresses and the password strength should be of a certain type. So we have implemented that as a requirement. So I'll be using test here, but I'll use test@email.com. For password, I'll give it a good password which satisfies the requirements of the project. Okay, there we go. So test@email.com, and so this is our home page. So I'll quickly go through the process of adding a new device and deleting it and sending and seeing the weather forecast. So we have an update. So we can see the user info is shown on this card here, email, name, and last access. So if we press the update button, we can change the name to, let's say, Manoj. We can change this to manoj@email.com. We'll keep the same password and then we'll update it. So you can see that my user information and username has been updated successfully. Now on going on to adding a device. So let's say if I have to add Manoj device and register it, you can see that a device has been registered and an API key has been generated. I can also delete this device. Pressing this button usually deletes it. So it's been successfully deleted. I will add again the same device. I can also update the device name. So from Manoj device, I can do Dario device, and then it successfully updates this device. We can also view at the weather forecast for the next 3 days. So latitude for Tucson is 32.3, I suppose, and minus 110.3. Yeah. So we get maximum temperature, minimum temperature, and UV for the next 3 days from the current location that we have. So we have seen update activities. We have also implemented a navigation bar up here, and I'll be going through it in the next part. So this is the home page. This is my home page, and I have recorded actual values from Photon device on this, and I'll be showing you what a user interface looks like on this app. So to begin with, we have set up a navigation bar which goes on to the activities tab. It also goes to the update info, update devices, and from the summary menu we can go to check the summaries of the other users and the proximity users. So firstly, I'll go through the activities tab. You can see that we have generated a table of the average activities. So each activity is numbered, is ordered serially. We have the date of the activity here, the duration for which the activity lasted, the UV exposure, average UV exposure, average speed, the activity type, and the calories burned during that activity. When the user clicks on this activity, there are two plots that come up. One shows the average UV exposure for that activity, uh, for that activity samples, and it also shows the speed for all the time intervals the data was recorded. So there are a few good graphs that we can see on this tab. We can see that uh, so this is one of so this on this page the user can see his own progress and manage the activities that were recorded. If the user goes to the summary tab, he can choose to show the data for a comparative data for other users and himself. So if you see, we have four comparison plots that we have plotted here. So one is the average UV, the average speed, and if the user hovers over the activity, they can see what was the average speed that was recorded for them and what was the average speed was recorded for all other users in on the database. uh, I would want to show you that the website has been made responsive. So if you can see the plots usually reduce in size, and uh, after a fixed length, they become column wise, and we can see that they have been arranged in one column. We also see that the navigation bar has been changed to a site nav, and from here we can access activities and all the other info. So if you see, the table also has been modified according to the size of the device, and if we go on the plots, we can see that they have been arranged in a column wise fashion. Uh, and we can also go to the main homepage from this page, and we can see that all the other pages have been made responsive. So in so I would like to uh, so this is the ECE 513 project. So the front end requirements that we have met are that we have created a strong password during registration. We have created new users, and we have capability of updating their information. We can add and delete devices. User can see the weather and the UV forecast for the next 3 days. User can see the data collected and compare the data with the users, close by users, and all the users on the device. We have made the website responsive so that the user can use it freely over a variety of devices. Uh, so we have actually interfaced the particle device to the server and created a website for users to view and keep track of their daily UV exposure, along with speed and calories burned. So this app has been a great. This app has great potential, and we have had fun implementing this project. Thank you so much.